All right, we're back. I want to give you some examples before your worksheet, but here's what I need you to do. I need you to find a periodic table. Now, of course, there are periodic tables all around our classroom, but they're huge. So there's one inside your chemistry book. So if you have your book, which you probably don't, I want you to get up, go look on the bookshelf, and get one. All right? Looks like this. It's a big red book. All right? Quick. I'm going to give you a little bit of time. 10, 9, 8. Everybody should be getting up right now. Go get a chemistry book. You're going to need a periodic table. Okay? When you get your chemistry book, right, come back to your seat, and I want you to turn in the back flap. This is the back of your chemistry book. You're going to open it, and you should see this periodic table of elements. Okay? And this little thing is going to be very important in your whole chemistry career with Ms. Baldwin. We use it a lot. Okay? Every element. Does everybody have one? Good. All right. Back flap periodic table. Now, once again, we're talking about atomic structure. All of our atoms, the ones that we've created, the ones that are in nature, are on this little periodic table, right? We can see that we have helium, we have boron, carbon, nitrogen, all different colors. Some are solids, some are liquids. All right. But what I want to do now is I want you to find magnesium. Do you see it? Can you see it on the screen? Where is magnesium? I see it. Magnesium is right on this side. Which side is it? It's right here. Now, the number at the top of magnesium says 12. That means magnesium has 12 protons. So here's an example. The element symbol is what is the letters. The element symbol is letters. So I'm going to write Mg. See that? This is the symbol. Can y'all see? Here we go. That's the symbol for magnesium. Now, magnesium has protons, has neutrons, and it has electrons. Okay? This is what I want you to write on a separate sheet of paper. See that? Protons, neutrons, and electrons. Now, we're going to figure out how many of each. The number at the top of magnesium square is the number of protons. It's also called the atomic number. So what number do you see at the top of magnesium? I see a 12. Hopefully you see that too. Everybody see 12? Good. So beside protons, you're going to write the number 12. Right? See that? Good. Now, neutrons. The number of neutrons is the atomic number subtracted from the atomic mass. Now, let me explain what that means. Look at your periodic table. By magnesium, right? Do you see a number in the square for magnesium that says 24.305? Good. That is the atomic mass. So that number is the number of protons and neutrons. It's the mass of the atom. It's everything that's in the nucleus. So if the 24.305 number includes protons and neutrons, and the number above magnesium that says 12 is just the number of protons, if we subtract the top number from the bottom number, we will just have the amount of neutrons. So for magnesium, you would take 24.305. You can make it a whole number, just make it 24, and subtract 12. And what number do you get? You get 12. So magnesium has 12 neutrons. Okay? So you're going to write 12, right? See my number 12? Oops, there you go. See it? I'm going to say that again because I think some people may have gotten confused. Is it okay if Ms. Baldwin says it again? Okay. I want you to look at magnesium. Okay, I'm going to try to put it in front of my screen. Do you see? This is the wrong side. Magnesium. Okay. There's a 12 in there. And there's the number 24.305. The 24 number is what's called the atomic mass. It includes protons and neutrons, two subatomic particles. The top number, the number 12, is just protons. So if I take the top number, the just protons number, away from the atomic mass, the 24 number, which is protons and neutrons, I'll simply have neutrons. So we did 24 minus 12 and got 12 neutrons. Okay? Now, last subatomic particle is electrons. You see it? Now, magnesium, the way I've written it, is just Mg. So it is a neutral atom. That means the number of positives, can you see it? Let me see if I can point. The number of positives has to be the same as the number of negatives. So if it has 12 protons, it has to have what? You're right, 12 electrons. So go ahead and write that. So a neutral atom of magnesium, ladies and gentlemen, has 12 protons, 12 neutrons, and 12 electrons. Get it? Got it? Good. Now, here's where it gets tricky. And don't get an attitude because I'm going to see you through it. What if I wrote magnesium as what's called a cation? A cation is something that has a positive charge. Okay? So instead of writing magnesium, what if I wrote magnesium plus 2? Okay? That means it's still magnesium, but it has a positive 2 charge. So I'm going to do my 3 subatomic particles again. Protons, neutrons, and electrons. Now, how many protons, can you see it? How many protons would magnesium 2 plus have? Yeah, I want you to think about it. How many protons would magnesium 2 plus have? Some people are saying 12. I hear some people saying 10. I hear some people not saying anything because they have no idea. They're like, Ms. Baldwin, I don't know what you speak of. All right. Well, are you ready for the answer? I don't think you're ready. I think... Okay, now you're ready. Magnesium 2 plus, right, is still magnesium, okay? What do protons do? Protons identify the element. So because it is still magnesium, it has to have 12 protons. If I have 10 protons, let's look. I would be neon. If I have 14, I'm silicon. In order to be magnesium, you see that number 12 at the top of the square? It has to have 12. Any more or any less, it's going to be a different element. So the number of protons for magnesium 2 plus is going to be 12. Okay? So, you see it? Let's see. There we go. You see it? Cool. The number of neutrons, 12. Remember, we calculate the number of neutrons by taking the mass and subtracting the atomic number. So the 24.305, or regular whole number 24, minus 12 gives us 24. Here's the tough part. We got to find electrons. Now, for the electrons are negative, protons are positive. Somehow, I have to be left with 2 more positives than negatives. So how many electrons can I have? I need 2 more positives. See this little charge? Let's come over here. I need 2 more positives than negatives. I need 2 more protons than electrons. How many electrons? Did you say 10? If you said 10, you are amazing because you are right. We would have 10 electrons. Okay? So let's recap. For magnesium 2 plus, I'm going to have 12 protons. Why 12? Because it has to stay magnesium. 12 neutrons. Why 12 neutrons? Because it's the atomic mass minus the atomic number. 24 minus 12 is 12. And I'm only going to have 10 electrons because the charge has to be plus 2. All right? I have to have 2 more. Now see, I have to have 2 more protons, the neutrons, in order to be left with magnesium plus 2. You get it? I hope so. Can I give you another example? Okay. This time, we're going to go negative. Let's say we're going to talk about nitrogen. I want you to take a minute, find nitrogen on the periodic table. Okay. Now, I've given you 2 examples here. We're going to do nitrogen, regular nitrogen, and nitrogen minus 3. So let's start with regular nitrogen first. Okay. How many protons? Did you say 7? Good. 7 protons. How many neutrons? Did you say 7? Good. And how many electrons? It's going to be 7. You're right. It's going to be all 7s straight down. Can you see it? All 7 straight down for nitrogen. 7 protons, 7 neutrons, and 7 electrons. All right. Now, this time, we're going to do nitrogen minus 3. That means it has 3 more negatives than positives. 3 more negatives. The only subatomic particle that is negative is electrons. So, in essence, this minus 3 means it has 3 more electrons than protons. So, how many protons, neutrons, and electrons is nitrogen minus 3 going to have? How many protons? Did you say 7? You're right. It has to have 7. Why? If it's anything other than 7, it will not be nitrogen. If it's 8, it's going to be oxygen. If it's 10, it's going to be neon. In order for the atom to remain the identity of nitrogen, it cannot have any more than 7 protons. Okay? How many neutrons? 7, because we're going to take 14 minus 7, the atomic mass, minus the atomic number, and get 7. Here's where it gets tricky, ladies and gentlemen. We are down to the electrons. How many electrons for nitrogen minus 3? Did you say 10? Did you say 10? You should have, because if you did, you are correct. All right? 10 electrons. Remember, this minus 3 means I have 3 more electrons. So if I do 10 negatives with 7 positives, I'm going to have 3 more of these than I do of those, thus making it nitrogen minus 3. If it's regularly neutral, it will be all 7s. If it's N minus 3, there's going to be a difference between the number of protons and electrons. Well, class, I think we've got it. I think we've kind of got the hang of atomic structure. There's going to be a couple worksheets coming around. I want you to use what I've taught you. Use what we went over to fill in those charts with atomic structure. Remember, protons identified, neutrons at weight, and electrons vary the charge. Here's Ms. Baldwin. I love you. Be good. Bye.